Welcome to Group 5's tutorial. For today's video, we'll be working on three things related with derivatives. First, we will solve and find the derivatives of the functions using the basic rules. Next is we'll solve a real-life function using differentiation. And lastly, we'll use again the basic rules of derivatives, but this time we'll be solving a complex function. So, let's start with solving the derivatives of the functions using the basic rules. In calculus, there are tons of rules on how to find derivatives. But in this video, we're just gonna start off with the very basics. The first is the constant rule, which is the simplest rule. In this rule, if the function is f of x is equal to c, which is a constant, then the derivative would be 0. Because every constant number in a function has a derivative of 0. That's why if you notice the examples given, the derivatives are all equal to 0. Let's move on to the next rule. Constant times a function. If you are familiar with the power rule, this rule will be easy for you. Just bring the power in front of the coefficient, reduce the power by 1, and then simplify your answer by multiplying by the coefficient. We will now go to the product rule. In this rule, we'll use f of x times the derivative of g of x plus g of x times the derivative of f of x. Product rule is used when differentiating two functions that are being multiplied together. Here is an example. F of x is equal to 3x plus 9 times 4x squared. The first function is denoted as the f of x, while the second is the g of x. So the derivative of f of x is equal to 3x plus 9 times 8x plus 4x squared times 3. Distribute 8x to 3x and 9, plus the product of 4x squared and 3. It will be 24x squared plus 72x plus 12x squared. Simplify the answer by combining like terms. And the answer would be the derivative of f of x is equal to 36x squared plus 72x. Fourth rule is the quotient rule. The quotient rule is actually the product rule in disguise and is used when differentiating a fraction. For this rule, we'll use g of x times the derivative of f of x minus f of x times the derivative of g of x over g of x squared. The given example is f of x is equal to 3x plus 1 over 4x plus 3. The derivative of f of x is equal to 4x plus 3 times 3 minus 3x plus 1 times 4 over 4x plus 3 squared. Distribute 3 to 4x and 3 and distribute 4 to 3x and 1. And then we'll combine like terms, which will become the derivative of f of x is equal to 5 over 4x plus 3 squared. Next is the chain rule, which is a rule for differentiating compositions of functions. We'll be solving just an easy one for this rule. The function y is equal to the function x squared plus 9 raised to 6. Use the power rule. Take the power in front of the function and then reduce the power by 1. Then multiply it with the derivative of the function x squared plus 9. Simplify your answer by multiplying 2x to 6, which will give you the derivative of f of x is equal to 12x times the function x squared plus 9 raised to 5. Last, for the first part of this video, is implicit differentiation. We are given 3xy plus 3y squared is equal to 11. Get the first term, which is 3xy, and solve. X times dy over dx plus y times 3 is equal to 3x dy over dx plus 3y. Next, get the second term, which is 3y squared, and solve. Multiply to 2y times dy over dx is equal to 6y dy over dx. Last, combine two terms. (3x dy over dx) plus 3y plus 6y dy over dx is equal to 0. Transpose 3y, which will make it negative 3y. Factor out dy over dx. Divide both terms into 3x plus 6y. which will give you the answer dy over dx is equal to negative 3y over 3x plus 6y. The second part of this video is solving a real-life problem using differentiation. Here is an example. The Jesene company can produce a V12 injector pump. Given a function of 6x raised to 4 plus 4x cubed plus 2x squared plus 140 and x is equal to the number of injector pump, what is the rate of change if Jesene will produce a 30 injector pump? So we are asked to find the rate of change in the problem. Use the constant times a function and constant rule. Take the power in front of the coefficient and then reduce the power by 1. Then make the constant 0. And after that, simplify. We now have the derivative of the function, which is 24x cubed plus 12x squared plus 4x. For us to get the rate of change, given that x is equal to 30, replace the variable x in the function with 30. It will now become the derivative of 30 is equal to 24 times 30 cubed plus 12 times 30 squared plus 4 times 30. Simplify it and we'll get the answer 658,920. So if Jesene will produce 30 injector pumps, then the rate of change would be 658,920. And the last part for today is the higher order derivatives. We'll find the first, second, third, and fourth derivatives of a complex function. We are given here an example. Y is equal to 8x raised to 4 plus 6x cubed minus 9x squared plus 10x minus 3. To solve the first derivative, use the constant times a function rule, which is taking the power in front of the coefficient and reducing 1 on the power. Plus, use the constant rule in the constant. The first derivative of the function will be 4 times 8x cubed plus 3 times 6x squared minus 2 times 9x plus 1 times 10x minus 0. If we simplify this, it will become 32x cubed plus 18x squared minus 18x plus 10. And that is the first derivative. Just repeat the steps to find the second, third, and fourth derivative of the function.